Okay, everybody, Mr. Taylor here. Now that we've gotten some type of understanding of 8.6c in class, let's take a look at 8.7c, which asks us to use the Pythagorean theorem and its converse to solve problems. So, without further ado, let's take a look at a couple examples. Again, definitions, 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 concepts, concept, concept. Please remember what a right triangle is. Please remember, especially there's two short sides are the legs, and the hypotenuse is the longest side. So when we're looking at that converse, no matter how that's set up, that longest side is going to always be the hypotenuse, and your two legs will be the two shortest sides. Very important information here. And then, of course, the Pythagorean theorem itself, we can represent it verbally. The sum of the squares of the leg of a right triangle equals the square of the hypotenuse. Or we can do so by that formula by saying a squared plus b squared is equal to c squared, where a and b represent the legs of the right triangle and c represent the hypotenuse. Always keep in mind, should I say, that when solving for a, b, and c, both the positive and negative numerical values should be considered, but since the applications are measurements, the negative value do not apply. Okay, let's take a look at an example. In this particular example, we have two squares that are formed by a leg of a right triangle, and notice this one says 45 units squared, the other unit says 64 units squared, and they ask us to find the length of the hypotenuse. Well, they have already squared a and b for us, so only thing we have to do from here is add, well, first put your formula, a squared plus b squared is equal to c squared. So a is 45. 45 has already been squared. That's why you see the unit squared here. 64 is already unit squared. That's the area on the inside of the box of the square. So we're just going to add them. 45 plus 64 is equal to c squared. If you add these, you'll get 109 is equal to c squared. To isolate c, we take the square root of not only c, but the square root of 109. Those of you that's wondering, well, how am I going to get c out of this? Remember that if we have a particular variable and we take the variable times the variable, we're looking at c to the first times c to the first is c to the 1 plus 1, which is c squared. So this is why we know that if we take the square root of c, that's going to be, or should I say, c squared. That just means that we're going to get c. All right, so again, the negative value do not apply here, and we will get 109. We take the square root, we'll get this particular part, the length part is 10.44. All right, let's move. So here we ask again to find the length of x to the nearest 100. X is going directly across from the right angle, so don't be confused here. X is just simply c. So they ask us again to find the length. So notice with this particular problem, the b has already been squared. So whatever the length is, it has already been squared. So that gives us 4096 meters squared, but this one has not. Okay, so keep that in mind as we go through and work the problem. And again, they're asking us to find the length of x. So once we square this, 45 times 45, add it to this, then we'll take the square root to get that part. So let's see what the author tells us to do. All right, so this is from this problem that we just did. It says a squared plus b squared is equal to c squared. Notice they did not square 4096 because it said unit squares on the other page. Plus 45 squared is equal to c squared. So here 4096 plus 2025 is equal to c squared. Add them up. you'll get 6,121 is equal to c squared. Again, to isolate c, take the square root of both sides. You would get a plus and minus 78.24 approximately, but we're not going to use a negative. So that means the length of that hypotenuse was 78.24. All right, outstanding. Let's keep going. Now, we said that we were going to look at some problems, and this will be pretty much the focus point from as we go forward. So here we have a telephone pole, and it's 36 feet tall. So we're talking about the vertical component. So if we were to label this, we will be talking about B. And a telephone wire is 45 feet, and it's stretched from the top of the pole to the ground. So this would be our C. And they asked us to find the base, how far it is from the base to where the wire is. So what we're doing is make sure that you understand we are taking a squared plus b squared is equal to c squared. Now, we know that a we don't know, so we can rewrite that as a squared plus b is 36 squared is equal to 45 squared. Now, a student told me today in my 7th period that he had a different approach for doing this, and I really like it. So he says when you know C and you're solving for a leg, what you want to do is take C, in this case, which is 45 squared, subtract from it the leg that you know, which is 36 feet squared, and that's going to give us our missing leg in this case, which is a squared. So if we did that, what we will get is 2025 minus 1296, and that's going to equal to a squared. We will get 729 is equal to a squared. Take the square root of both. And this will give us 27 is equal to a. Again, we're going to forget about the negative 27. I really like that concept, and to make it easy for you where you won't think about adding or subtracting from both sides. Just remember that when you're solving or you've already given the hypotenuse, just square it, square the missing leg, subtract it, and then solve for your value. Again, square the hypotenuse, square the leg that you know, and solve for the missing leg by taking the square root. Pythagorean triples. Pythagorean triples is a really nice little concept that you should maybe think about learning. The least Pythagorean triple is 3, 4, 5. And if we take any type of scale factor and multiply 3, 4, 5 by, regardless of what that scale factor is, as long as we multiply every single number by that, we will come up with these Pythagorean triples. And these Pythagorean triples is just a good way of understanding and remembering whether or not we have a converse. So, yeah, maybe I think we're going to get off into it. But let's take a look at 3, 4, 5. And if we multiply 3 by 2, 4 by 2, and 5 by 2, we will get 6, 8, and 10. That is another Pythagorean triple. Then, of course, if we multiply 3, 4, and 5 by 3, we will get 9, 12, and 15. And if we multiply each one by 9, we'll get 27, 36, 45. There are myriads of these, but what you want to do is remember this first one. It'll be nice if you remember these two, because you can also come up with a scale factor for these and create more triples. If you have any questions on that, please bring that up. This will just be easy for you when you're looking at these converses. All right, let's move. So again, we talked about triples, so right the very next thing we want to look at is these converses of Pythagorean theory. Well, from a verbal standpoint, it says if the sum of the squares of two sides of a triangle equals the sum of a third side, then the triangle is a right triangle. If the sum of the squares of the two shortest sides equal the side of the third side, then it's a right triangle using this particular formula. So, good example, they told us to take a look and see if 12.1, 4.9, and 8.1 are right triangle. Now we need to make sure we know that we're just going to take the two shortest legs. So the two shortest leg is 4.9 and 8.1. No matter how they have this is not A, B, and C. This is A, B, C. So we'll rearrange that and square 4.9, square 8.1, add these together, and then square 12.1. So if you square these two, you'll come up with 24.01 plus 65.61. And if you add that together, well, should I say, you'll get 89.62. And if you square 12.1, you'll get 146.41. And notice 89.62 does not equal 146.41, meaning that it does not form a right triangle, or does not form a square at the base. So no right triangle here, according to the converse. Well, what about if we determine 3.81? So 3.81 is one small one. So then I got 5.08, and that's must equal to 6.35. So if we squared 3.81, we would get 14.5161. If we squared 5.08, we get 25.8064, and that's must equal to 6.35 squared is 40 plus 0.3225. Add these two together, you get 40.3225 on both sides, thus forming a square at the base, which is a right triangle. All right, so here we want to take a look at a real good exercise. This one, we're going to do some things as far as creating this diagonal. So the student athlete's swimming pool is a quadrilateral that appears to be in the shape of a rectangle. The length of the pool is 14.24 feet, and the perimeter of the pool is 1,678.08 inches. The diagonal of the pool is 57.21 feet. So that means if we take and cut this right here, we will get this. So to solve this problem, the very first thing we're going to have to do is go back and look at this particular number, which is 1,678, and we're going to have to convert that to feet. So we can do so by saying 1 foot is 12 inches, and 1 time that, or then 12 times that. Your inches goes away, and literally let's do inches going away. 1 times 1,678.08 and 12 times 1. So in essence, you're just literally dividing by 12, and you get 139.84. So now we have a perimeter is 139.84. So in order to find what each side is, we will take the formula for a perimeter. P is 2 times the length plus 2 times the width. So we know that the perimeter is 139.84. Substitute P in your formula. And we know that the length, they gave us the length, and the length is 14.24. So we multiply 2 times that plus 2W. So we're just creating a formula. By now you should be pretty familiar with what we're going to do once we get 2 times 14, which is 28.48. We're going to subtract it from both sides. Here we get our 0 pair. Subtracted from this, we get 111.36 is equal to 2W. To isolate W, we divide by this coefficient in the front, and we'll get W as 55.68. So the width of the pool is 55.68 feet. Now, the next thing it asks us to do is to determine if the length, width, and the diagonal of the pool forms the right triangle. So we'll take the 14.24, we'll take the 57.21, which is our diagonal, and then we will take what we just solved for, which is the width, 55.68, set up our a squared plus b squared is equal to c squared, and use the converse to see if this is indeed a right triangle. So in that case, if I square 14, if I square 55.68, it must give me 57.21 squared. So going through the math, 14.24 squared is 202.7776 plus 55.68 squared is 3,100.2624, and that must equal to 57.2 squared is 3,272.9641. If I add these together, I'm going to get 3,303.04, and that is not equal to 3,272.9641. So what that tells me is this measure do not satisfy a Pythagorean theorem, indicating that the angle of the pool is not 90 degrees. Okay. I hope you were able to get something out of this. Just go back and look at the lesson and look at the lesson and look at the lesson until you, especially this last problem dealing with these converses, because you'll see something real similar to that real soon. This is Mr. Taylor. Thank you guys for joining me. Have a great one.